Okay, hello everybody. Let's proceed to the next panel. I invite on the floor Professor Alexis BIRBAS from University of UPatras. Okay, Chrissavgi, Deputy Director INTRACOM Defense. Grigoris, ZISIS, Business Development Manager in OAB, and Michalis DRITSAS, Policy Officer from the Minister of Finance, Economics, Finance. Okay, I welcome you all. I will start around the first round of questions with Professor BIRBAS. Professor, in Greece, the Hellenic Chips Competence Center is positioned as an interface to design and technology services for startups and SMEs. So my question is, which 2 or 3 very specific design sectors, domains, and consequently subsidized support will create the biggest prospects and impact on SMEs in Europe and in Greece particularly in 2026, and how would you finance and scale these activities?
Okay. Thank you for the question. Let's put first in the perspective, because this question is the million-dollar question for everywhere. Where you put your money on in the chips domain. I would say that, as Romano said, and the previous panel discussed about, we have a shifting from, let's say, the CHIPS Act objectives and targets, which were very ambitious, but they are not to be fulfilled, apparently. But I think it is, we need another CHIPS Act and changes in general to focus on what we need as Europe firstly and as Greece secondly. We have a shift from, let's say, don't forget that the CHIPS Act 1 established after the pandemic because of this value chain crisis, okay? Supply chain crisis. This is not anymore true. Now we have this geopolitical stuff and this geopolitical war, and everybody talks about sovereignty regarding the technology, okay? So it's a different story. So your question is valid in the sense that we have to find what, firstly, are the strong, let's say, sectors in Europe to invest on, and what their needs for microelectronics on these sectors, and how can Greece be, let's say, positioned in that environment. Let me think just the big sectors for Europe, just being the telecoms, for example, traditional big sectors, automotive, industrial manufacturing, and I would put as a fourth one, the defense, which is now the main focus areas in Europe, and we're talking about that. But since I have the privilege and the honor to lead the European SNS hardware community, I mean, which is the new communication technologies, I'm leading this, I'm chairing this committee regarding the hardware development in the future to support, you know, the evolution of 5G to 6G, etc. Let me tell you that it's very difficult also for us to define what we do. For example, let me give you an example, and then I will come to the SMEs in Europe and Greece, because this is the main topic of HCCC. That's why we established this HCCC, in order to help Greek SMEs go forward in the microelectronics domain. If you consider, for example, the industry, in telecommunication industry, we have 2 big, I mean, world players in that. We have Nokia and Ericsson here in Europe. So we have the strong foundation to start thinking about what we do with them. But if you open the microelectronics needs, for example, for the next wireless communication technologies, you have, first of all, you have to exclude what we call the digital enclosure. Nobody will consider in Greece making baseband processing chips. No way. Everybody will take an NVIDIA card and will put this in there and will program it, and then there's no way to match it. This is a big difference. So you have to find where you have the strength to do that. And the strength we have probably is in the analog and the RF domain. Fortunately, in Greece, we have startups working in this area because we have good traditions on that. We are not so back. We're actually in par with China and the United States. So that's a sector to focus on. And then we also have the ingredients to make, this kind of microelectronics evolution, because we have good now, let's say, fabrication lines in Europe regarding, for example, power electronics, gallium nitride, silicon germanium, this kind of technologies. So we have also other companies which can support this one, bigger companies. We have Infineon, we have ST Microelectronics, we have all these kind of technologies. So the answer to your question is that we have to find in each big European sector where the niche markets for us, and we focus on that. Of course, nobody can tell a startup in Greece, starting from a university or from an academic institution, not to have ambitions, to be the next media, but it's going to be very difficult. Okay. It's better to fit in what are the needs for the ecosystem, the greater ecosystem in Europe, and try to give solutions in that. Okay. That will make also scale up and growth.
Okay, thank you very much, crystal clear. I proceed with the second question to Chrissavgi. Over the years, we have seen solid touch points between INTRACOM defense and the local knowledge base. What have been the main types of collaboration between IDE and domestic universities and research centers in the area of microelectronics so far? And what, according to your experience, have been the major blocks for enabling a deeper and perhaps more permanent relation?
Thank you for your question. Actually, INTRACOM Defense is a system company. We mainly do electronic design for various applications like communications, surveillance systems, unmanned systems, or hybrid power systems. In all of these, chips are mainly assets for our product, so we need collaboration with all the ecosystem. We all know that the Greek ecosystem and the academia has much high level in research activity, so we actually do collaborations with almost all the universities, and we have involved them in many R&D projects that we coordinate through various EU frameworks, like European Defence Fund or Horizon projects, in projects that we coordinate. We have also great collaboration with the research centers, like Katerina mentioned before, Dimitris and CERT in Thessaloniki do the excellent work in combining the dots with the whole ecosystem. And we also have direct contracts with academia. Okay, is everything okay? There are no any blocks for collaboration. Having experience from the past, since I did my PhD at the University of UPatras many years ago in microelectronics, what I have seen the last years is that Greece was in an economic crisis for many years. This has impacted a lot in many things, and especially in microelectronics. Because when we do hardware and embedded design, we need expensive infrastructures. And this is not the case when you are in a country that is in economic crisis. So at that time, I think we lost much talent people and engineers from this domain. So right now you see many lack of experience to engineers. We all know that the next generation, our children, that are also in this domain, they hear the trendy words of AI and cyber, and to stop there. Chip is not a trendy word, so I think that the initiatives like Europractice and the one that Mr. Hoffman mentioned before is important to be disseminated along our people, and not to stop at the two trendy works right now in all the universities' studies. We also see that there was absence of some special frameworks, especially for dual-use technologies in microelectronics, and this is a barrier too. Also, the Greek academia was not aware of the specific needs of our defense industry and the security industry, and this is a barrier too. But I think this is changing this time because, for instance, the LCAG, which is the great work for the Hellenic Innovation Center from the Hellenic Ministry of Defense, I think it does much good work now to promote dual-use technology in Greece.
Okay, thank you very much. Going to Grigoris ZISIS. Grigori, Europe treats space as high-stakes domain for sovereignty, Earth observation, navigation, defense, infrastructure, resilience, all depend on trusted compute. My question is, why is the space sector considered a strategic priority in Europe's semiconductor strategy, and what challenges does it face in securing reliable chip supply?
Yeah, thanks. So I think that the space sector is actually it's not just a priority of the semiconductor strategy, but it's more like a fundamental component of the broader European strategy, as it ensures security, defense, and global influence in general. It's the strong dependence of the space sector in semiconductors that basically links these two sectors together and also aligns the strategy. And historically, the defense sector, along with the space sector, were the key driving forces towards further development of more advanced semiconductor technologies. Space, in particular, poses significant challenges to the semiconductor supply chain. Chips must be reliable under extremely difficult environment. And also, another issue is that space is not considered as an attractive market for the semiconductor industry because of the low volume of manufacturing they have.
Okay, thank you very much, Grigoris. The next question is from Michalis DRITSAS. Michali, across Europe, the bottleneck isn't ideas, it's industrialization, getting from promising prototypes to repeatable, certified, costed products in live supply chains. My question is, what is the one critical gap in Europe's research to industry transition today, and how can pilot lines plus competence centers close it in the next 12 to 18 months?
Thank you for the question. The greatest challenge for Europe is to narrow the gap between US and China, of course. We all know that. And we know that CHIPS Act was the enactment of a tremendous effort from Europe's side to close this gap. And what is missing is the time to market from the design stage to the fabrication stage. And Europe needs to invest a lot of money and is trying to do that through various initiatives. I will mention some of them that Greece also participated. It's the IPSEI projects, which stands for Important Projects of Common Interest. And we also participated as Greek government financing companies in this domain in terms of microchips. At the same time, we also invested money in the establishment of this dedicated HCCC competence center, which compared to other competence centers that we established previously, these competence centers came out from a competitive procedure, bid, but this one, we needed to put money, to match money from the European Union in order to cover the 50% of this investment, which we do consider it as a very pivotal investment because this organization is going to play an integral role in the whole ecosystem here in Greece and also as a means of connecting the dots with the European ecosystem. So we do expect a lot of this new entity. At the same time, there is a new initiative from the European Union. It's called STEP, the Strategic Technologies for Europe platform. Greece joined this effort. We are going to invest approximately 350 million at this point in this direction in order to facilitate research and innovation in industrial capacity, as well as training and development in specific sectors which Europe considers as very critical for its future. And this one among these areas is the microchips. So we are here to help the whole ecosystem in order to secure money for the pilot lines, money for R&D for proof of concept, but also for training and development, because we do need new skilled researchers and also technical staff for these pilot lines. Thank you.
Thank you, Michalis. Going back to Professor BIRBAS, co-design isn't a slogan, it's real-world guardrails and data sharing. So my question, Professor, is what is the minimum set of shared data and common tools a small IC SOC team needs to do effective DFM, DFT co-design? Is access to a pilot line a necessity?
Okay, thank you. Let me first add something to what I heard from Mr. ZISIS before. I think also HCCC's role is also to not only to make, this kind of technology and availability and inform all the community here in Greece, but also I think main target for us should be also to make strategy and advise the state what to do with microelectronics in Greece, because I don't think there is any kind of guidance right now what to do there, because the environment is so liquid, around Europe. So it's not easy to make policies, but one of the main targets of HCCC is to make to advise or say to recommend to the state what to do in the microelectronics in the future. And also, I'm telling you this one because we're going to see a lot of things here globally. For example, you see now the US government in the Trump era investing in Intel, a state investment in Intel. This is out of mind. I mean, you can see that JSR, which is the biggest provider of photoresist in the world, the Japanese government takes equity out of it in order to delist this from the exchange, in order to protect from a buyout. This is, we're going to see things which are amazing, around the world. So first priority for Europe, doing all these things you mentioned, is that to protect the gems. This is, to my opinion, ASML, ZISIS, this is also one, and maybe some other one which I'm missing, but we have to protect these valuable companies. Now coming to your question is that, of course, if we're talking about shared data, definitely in the community we have to have the foundry PDKs available. That's the first set of shared data which will be available to the community. The second one is the health and defected data. For example, either historical or from the various processes in order to be available for the designers. Also, we have test and coverage metrics and fault models, and also manufacturing feedback loops, which means that we have feedback from the manufacturing domain regarding the faults, etc. This is the kind of data should be available in the community in order to make effective designs. And if we are talking about common tools, I take the word from Romano. What I heard from Romano regarding UPatras is very, very helpful and going to be very, very promising. Definitely, we need also DFM analysis tools, designed for manufacturability design tools. We need also DFT tools, insertion tools. We need also repository tools in order to make tracing of various design versions, etc. And that's going to be a necessity in order to have this easily available to the community in order to promote the chips design. Also, coming back a little bit on your question is that I think as Greece, as a HCCC, we don't have to focus so much on the pilot lines for the SMEs. That's my idea. Because we have to go to born mature companies, to more mature technologies. I mean, they are there. There is much easily to be assessed and also to be accessed. That means that if you're going to, for example, to mature technologies like 22 nanometers FD-SOI, which is very, very common in Europe and provided by European companies, this is much better instead of focusing on the, the pilot lines for the time being. Of course, I don't exclude it, but not for the time being. And second is that we focus also on multi-project wafers and subtle runs from various manufacturers around the world in order to provide, this silicon manufacturing access to the SMEs in Greece.
Okay, thank you very much, Professor. My next question is for Chrissavgi. As Greece formalizes tech transfer through incubation programs, more structured IP frameworks, the opportunities to turn scouting into repeatable deal flow. And given that technology transfer mechanisms are being developed in Greece, has IDE a formulated policy on how to approach such matters? What are the mechanisms that you have developed to keep track of promising new startups, spin-offs, and researchers in this area?
Yes, very good question, especially because all these things happen in the last few years. So there are new things for Greece. This is very nice that we have all this technology transfer mechanism. As IDE, we have some mechanism for ourselves. We have a dedicated department that has deal with all these activities. So we are in close collaboration with academia and the technology transfer offices in order to learn about new things and see a possible collaboration. We have signed, or we are in the process of signing MOUs with various academia labs and research centers in order to be in the same ecosystem. For sure, we are in common association clusters, like the HETIA, that does excellent work, I think, in this microelectronics domain. We also, in common projects at the EU frameworks, that helps a lot for collaboration between industry and SMEs and academia. Right now, we are in the projects that we run right now, we are in collaboration with more than 200 entities around Europe concerning SMEs and universities and startups for new things. So this is the way that we work. And of course, we participate in conferences like this and any initiative that has to do with new technologies in the Greek ecosystem, in the European one too. Thank you.
Okay, thank you very much. The role of IDE is well known to build an ecosystem in this area. Now, Grigoris, for a subsystem integrator like OHB, Hellas, the challenge isn't just finding parts, it's stitching them into a certifiable, traceable chain that fits European cooperation for space standardization constraints on packages, temperatures, while charting a realistic path from coach to rad hard. My question is, from the perspective of OHB Hellas, what are the key limitations in sourcing and integrating semiconductors for space applications?
Yeah, thanks. So at OHB Hellas, we work towards developing high-performance computing devices. So basically, that are able to execute on-board satellites, AI models, or other advanced algorithms. So here in Athens, in our labs, we basically test different types of hardware devices, hardware accelerators like FPGAs, ASICs like TPUs or NPUs, or even neuromorphic chips. And sourcing now this and integrating such devices for space missions, it's a highly challenged task, And all these chips must, first of all, be radiation hardened. Okay, so the chips must be able to work reliable in space, which is something that introduces extra costs, and also it's time-consuming regarding testing. Another challenge is to solve an equation regarding the high performance versus the power consumption, which is also critical for OHPLS as well, for what we do. And a third point that is also relevant with the CHIPS Act, as we talk today, is that we actually find very difficult to outsource components that are made in EU. Okay, so I don't know if you were aware, if you were present in and noticed in the presentation that we had earlier, more technical from my colleague Alexis, all these hardware accelerators we test are basically US made. So we hope that HCCC also will help also towards this direction to elevate a bit the situation and CHIPS Act in general as an initiative. Yeah, there are some specific actions that I know, calls for to elevate specifically semiconductor for space activities, and I think they're in the right direction. But as Mr. BIRBAS also mentioned, you know, we need also a strategy on this, and quite recently, maybe a month ago, the Hellenic space strategy was released, and we, as OHB group, and we that have presence here in the country, we are very much support this initiative. But yeah, I don't remember that mentioning that we actually develop new niche things that we can actually also export from the country. Thanks.
Thank you very much, Grigori. My last question is for Michalis. Michalis, you are one of the members of the Committee of Strategic Development in University of Athens, the Center for Technology Transfer and Entrepreneurship, called Archimedes. So you are very up to date and working on technology transfer. My question is, what could we do to accelerate the process of technology transfer between our research centers and universities to the industry? And continuing with the same question, how can we monitor the performance of R&D in terms of impact on the economy?
Thank you very much. Everything started in 2021 when the Greek government decided to invest in technology transfer in Greece in a very systematic way, which means that we invested in the first round of the technology transfer offices in Greece in order to help them in terms of capacity building. And now the first round has ended, was quite successful, but it has a very limited time to deliver results. And now we have entered into the second round with 25 million gain, if I remember well. And we expect that in the next 5 years, this capacity building process will end up with very fruitful results. What we expect from the technology transfer offices is to learn how to help the spin-off companies in terms of formation, how they can protect the IP of these entities, and of course, how they can help these companies in terms of finding the product market fit, which means that they have to bridge the gap between the spin-offs and the bigger industry. And this is a huge challenge. I believe that we also need to get some know-how from very established technology transfer offices from Europe at least, or elsewhere, I guess. And this is something that we should look into it in depth. And at the same time, we facilitated the spin-off formation because we changed the legislative framework in order to make it easier for the researchers and the scientists to set up their companies without having big obstacles from internal, let's say, complicated procedures. At the same time, we also paved the way with the first 10 competence centers, and now we have the 11th in the microelectronics area, which was also something brand new in the Greek reality. And now we expect also the investments through the STEP call initiative, which will also facilitate the production of high-end products and services from the Greek industry. So, as far as the results are concerned, what every ecosystem has to monitor is how many new positions are established, direct and indirect, what is the value added of the products they produce, the exports. There are some very hard indicators which show if the investment yields back to the country and the economy and the society. So we have to keep a very good track of these figures.
What is the position right now of Greece in this area?
In terms of the position of Greece in terms of the microprocessor industry, we are in a very good position. We have a very strong base, industrial and design base, but we need to move to the next steps of the vertical integration. And we are here to help this ecosystem to become more mature and more competitive and more integrated with the European value chain. The word is value chain. We have to be part of this value chain. We have to find the niches that we are more competitive and invest in these niches. If we're a small country, we cannot be competitive in all aspects of microprocessors.
Okay, I believe we have time for 1 or 2 questions for the participants. I can't see. Is there any question? Okay, there is a question.
So, coming back into the dual-use case, which I think is an interesting. We know that dual use was kind of a forbidden word for a large amount of time, but now also Europe has started to understand that this is something we need to be doing. So how do you see, and this is of course for all the panelists, but mostly I would say for some of the panelists that actually are in this space, how do you see that dual use being accelerated? Because this can be a niche area where we bring our core competencies together and we get into the value chain. And this is for all of the panelists, given your different expertise. So if you want to start.
May I start first, please? As Mrs. Dre mentioned earlier, one initiative from the Greek government was to establish ELCAC, which is a new entity under the Ministry of Defense, aiming to produce prototypes which meet the needs of the Greek army. So this is one very, very important step, and it's very well designed because it is within the same ministry, and at the same time, they trace the needs of this ministry, and the calls they issue are very relevant to these, to address these needs. At the same time, we have also the NATO Innovation Fund and the NATO hub in Democritos, which also plays a very important role. So these two initiatives will help Greece to form a stronger design and industrial base, I would say, in order to meet the needs of not only for Greece, but for Europe too.
Okay, if I add something, what I have seen from my experience is that European initiatives like the European Defence Fund was really catalytic for dual-use technology, especially because they force the SMEs and the ecosystem of startups and academia in Europe to collaborate with the industry in this area. And I think this collaboration can help a lot and accelerate things for dual-use technologies. We all understand that when we have unmanned systems, we can have dual use for security and for defense. Sometimes there are specific processes that are needed for defense. Okay, you can have also this, but if we at least we can cover the dual use needs at the security level, I think this is a step for accelerator. And of course, the funding always accelerate things.
May I take the word again about funding? The Greek state is the biggest investor in terms of the venture capital ecosystem of Greece. All of these funds that you see around, which are approximately 18 right now, and we anticipate another round of 10 funds, they all get 80%, 70%, up to 50%, as the Greek state is the anchor investor. So these funds would not be existing here in Greece had the Greek state invested this money before.
Yep. Don't have a lot of things to add. I think dual use is the word of 2020, of the year, basically. We find a way, basically, to, to lift any barriers for people and institutes to participate in defense projects. This is my opinion. Since the funding is important, and nobody wants to left out.
Dual use technologies, I think, is important because not only creates some technology, cost reduction in general. Somehow eliminates the most of the risk, for investing in a defense technology, which is a niche technology, actually. This is the first thing. The second thing, which I would like to say, that it is the word of the year because it helps also to leverage the public opinion, because a lot of people, especially in Europe, have political objections regarding the defense. If you have a duality, dual technology, that means it's more easily acceptable to the public and also to the taxpayers in order to invest in these technologies. So it serves both ways, I say. But if we use the word duality, let me put a technical duality, which is also important, we're going to face in the future. For example, we have here Michalis, right? Grigoris. Grigoris, who is working in the satellite, okay? The new Eldorado in communications is considered a band between 7 and 15 gigahertz, which is the most, I think it's more accepted band in worldwide for deploying the 6G technologies, okay? This is a band which is, satellite band. That means that we have to find, to have both terrestrial and non-terrestrial communications on the same band. This is the duality. And that means the only way to serve this kind of duality is to do it through microelectronics. So the opportunities are there, in the duality in general.
Okay.
May I also add
one more comment, and we are out of time.
Last comment, yes. Greece is performing very well in the European Defence Fund calls. We rank in the position 4 or 5, and in Horizon Europe, we are in the 7th position, which means that we are very competitive in these domains. So let's take advantage of these funds. And one more word, STEP, the Strategic Technology for Europe platform, added a 4th pillar, which is the defense. So we also have calls for defense-related projects. Thank you.
Okay, thank you very much for your time, for being here. Thank you very much for your participation.